Very warm welcome back, everyone, again. Today's topic is a very important one and very very common topic for day-to-day web and mobile application developments, which is how do you go about navigating from one page to another page in an application? Because to be frank, you cannot fit possibly everything in one page. So for example, what I have in front of me is um, a Wikipedia page about React. Now, if you look at this page has multiple links. And if I click on any of the links, for example, if I click on React Native, my browser reloads and I go to a page with React Native. Now, what is happening underneath is when I am clicking on a link, browser is sending a request to Wikipedia server to fetch the entire React Native page. So what is happening is if I draw it here, this is a page with React in it. And this is the page with React Native in it. Now, Wikipedia is essentially when I request, my laptop requests the page, my laptop is requesting page, the Wikipedia server is serving one of these two pages whenever I request based on what URL I'm giving. This is so React, and here URL will be /React _ native, I believe. Now, what is happening in this is a traditional way of doing the web application development where you reload the entire page, and you might ask why. And then before we jump to why, let's look at how the modern React application works. So let me choose a different color. So modern React application, right? If it was showing same thing, there would be a section with React when user or our laptop is loading your application. And when our laptop is requesting React page, it loads this. So this is equivalent of portion of a page or part of a page, or in our terms, a component. It will load a component which shows React. So essentially, in modern React applications, you are loading a component and not the entire web page like this. So if you look at this, this is outer shell. This is entire page. This is entire page. When I request a page for React Native in similar manner, our application then rewrites the same thing with /React Native. And it loads the React Native component. Now, so if I zoom out, if we look at my screen, if I don't know if this is visible. If not, let me know, guys. I'll try to make it a little bit more visible. So this, in both cases, my laptop is requesting React and React Native pages. But in case of React, we are loading different components. And in case of traditional web applications, we are loading the entire page. Both are achieving the same thing. They are achieving the exact same thing. However, the benefit, you might ask, if we are achieving the same thing, why we even do this? Why don't the React library continue to use the normal mechanism? Because this is expensive process, loading the entire page, both for my browser as well as for the server. So both for my users as well as for me, this is expensive process. It really is expensive in terms of performance of an application, as well as uh, performance, as well as cost as well. Expensive in both cases. So doing this slows down your browser, because each time I have to fetch entire page. When you fetch entire page, you get entire JavaScript, entire CSS, entire HTML, all static content, like your images and everything. So best example, let's look at this. I don't know if this is not okay. That's good. So I'm on a page. Let me refresh this page. And I'm loading entire index page, entire blacklist JSON, a lot of different things, this image and everything from scratch when I load the page. When I go to, let me clear this now, and let me go to another page. I have to again load entire things. If you observe my browser, there are a lot of files that got loaded over and over again. This is slow on the browser itself. So the user sees a slow website, and this is expensive for me on the cost of server as well. Every time a request like this goes to a server, it's money spent by the Wikipedia company. When you're loading something from Wikipedia, and it is a cost that Wikipedia is paying for you to be able to load. So doing things like this has two benefits. However, in traditional ways, we can always do this. We can go back, we can go forward. And that is the problem that if you simply did the component-based routing, you would face. So you need something which is more robust, besides just replacing the components on the screen, to be able to support the browser-based navigation, which is back and forth buttons. And that's where one of our main topics of today, which is React Router, is going to be useful. So before I jump into today's project, into this code, any confusions on this? I'll hang here for a few seconds for you guys to ask any questions. All right, if no questions, moving on. Today's project is recipe books, recipes. So we have all kinds of recipes that we can have. Let's say if our application was a recipe detailing application or recipe book, we could have all kinds of recipes. And our initial page could show list of recipes, and then you could have a link just like we had in Wikipedia, where if you click on it, we load details about the recipe and the dish. And then we could do like this and load our recipes back again, or we could do like this and go back and forth. So this is we are achieving. But if you've been curiously noting my network tab, every time I do this, I'm only loading a handful of things like a recipe, and we'll see what that is soon. But if I did the same thing in Wikipedia, you'll see the bunch of things that get loaded. So that is the difference that I was describing, is by using the library React router and doing the things this way, we are able to still achieve the same mechanism of old web browser navigation back and forth with much less resources. So that's a simple application that we have to understand today. But underneath, let's see what is happening. And don't worry about the previous and the page 1 of 5. That's our topic 2 of the day, and we'll be covering very soon. But first, I want you guys to understand the routing and the mechanism behind the routing, because this is going to be something that you will again be doing day in, day out when you go to professional world and build real React applications. No React application is just a single page and single frame. You will be building a whole bunch of components, and you will be going back and forth between those components as means of pages. So that being said, let's dive to our application. So this is for today's application, we have imagined this is our database with so many recipes here, 25 recipes listed: pasta, then chicken tikka, taco, miso soup, Caesar salad, pad thai. So these are all coming from our database, and we'll see how they're coming very soon. But first and foremost, as I was saying, the library that is useful to let us achieve this is React Router. And this doesn't come inbuilt with React project that we create from Vite. So when you create your project, and if you're creating a new project with routing, you will have to do npm install React Router. So remember this, you will have to do this for the such kind of projects to run. Once we do this, then we are importing certain important things: browser, router, root, and link. So a link is a simple link, just like our anchor tag here, like talk or article or anything. A link tag is just like this, which we have on top of our recipe book, which is called recipe book, which helps you when you click on this, no matter which page you're in, it will route to the page you specify. And when I say this link to, our application has a mapping of what this dash means. So you could imagine a data structure like this, where each thing means something. Go to this page, and we see when we say something like this, recipe ID, go to another page. And what page? I mean, or in our simpler terms, go to another page means so another component. So in our application, we have built two components. Let's look at those components first, and then we'll go into detail of components, but let's assume we have two components: recipe list, which is showing the recipe, and recipe detail, which is showing the recipe details. I am telling through browser router and routes definition that, hey, in my application, these are routes. A slash means show me the recipe list component. Slash means your basic, no route parameter. So what you see selected in my screen recipe /3 is route parameter, and an actual route within my web application. This would be, let's say if I had a real application, this would be recipe.com. When you go to recipe.com, I would load the list thing. And if I did this recipe 3, I would go to recipe. So it's something like this. Imagine our local host being this thing. Then just this thing means our slash route. So when my application has no route mentioned, for example, let's do this for Wikipedia, what it means. Then it loads wiki/main page. I did not say take me to wiki/main page. It decided it needed to go to wiki/main page. So similarly, this is my default definition of what is my default component to shown on the screen when I do not specify a route. Then the second definition, line 18, means when I say recipe and the recipe ID, please show me the recipe detail. Similarly, you could have had another route which would say route path, and you could say when I want to look at my favorite recipes, please show me the favorite recipe component. So let's say if we had a mechanism to make each recipe favorite, we could have created another component, favorite component. We could have done something like this if we needed. So you can add as many as routes based on your application need if you want. So what this is doing is every time user requests the main page of our application, it's showing the recipe list component. Every time they are requesting recipe with the ID, it's showing the recipe details. And if I go to recipe list, our recipe list component has a state variable named recipes, which is list of these recipes. List of the recipes here, the 5 are shown with um, which are fetched from database. So this is the API calling we have seen in past. Similarly, which is loading nothing but our DB database, all this list of recipes, and not the list 2, but this one. This is loading all the recipes and then displaying 5 of those recipes at a time. So before I jump into why just 5 and why not all 25, any confusions on what it means to be going back and forth between pages and what React Router is helping us do? Moving on, let me refresh my page. Let me refresh this as well. So before I jump into this code, the problem that I want you guys to understand is, let's say if I had 1,000 or let's say 10,000 recipes, 1, then 2, then I could show a list like this, but how far I can go before killing my web page? You cannot put all 10,000 recipes at the same time on your page. And to overcome that, right? My system is painfully slow today. You could possibly not show entire uh, entire 10,000 pages, even if 10,000 recipes, even if you need it. So we use something called pagination. which essentially creates pages of predefined uh, number of items to be shown. So if I have 10,000, I can show 5 items at a time. Let's say if I had, instead of 1,000, let's say 100, so easy to calculate. I, then I'm breaking this entire list into 20 pages. So what I am doing here is, if you look at the code, I'm calling my API, which is returning me all the 25 recipes, but I am choosing to display only 5 of them at a time using the mechanism that is known as pagination. And pagination has 2 parts again. Uh, the example that we are seeing right now is called client-side pagination. It has 2 parts, client side and server side. So mechanism that you're seeing as of now on our screen is known as client side mechanism. And what do I mean by that? I am getting the entire data, all the 25 details from the server at one go. And then I'm on my React application choosing to conditionally display only 5 of them. So I am I'm chunking or breaking the entire 100 items, in our case, 25 items, into 5 items, and I'm only displaying them 5 at a time. Now, if I go to recipe list component, we are fetching entire list of 25, and then we are calculating that, hey, I want to show 5 items per page. So please give me number of total pages to calculate. So if we have 25 items, you can calculate easily. We would have 25 divided by 5. You'll have 5 pages. So I'm breaking my application into 5 pages. This is the number that you see here. And then I'm internally noting on the what page I am. And then I am slicing my array of 25 items based on current page and number of items to be shown. So if I go, so this is, I sliced from item 1 to item 5. Now, if I go to next page, my page number or the start index increases. So I am now slicing from number 6 to number 10. And this way, instead of showing all the recipes at the same time, I am just displaying 5 at a time. And this has massive performance improvements for your React application. In fact, in modern software development, pagination is so central to everything because all the applications, right, regardless of which application you're seeing, from your TikTok to your any other application, they have massive amount of data. They could possibly not show you everything in one go. So we are now showing only what fits the screen and what keeps application performance. Now, this is called client side because we have still fetched the entire list of recipes from server. And we have then decided to slice my items with 5 items at a time only in my React code. Now, this is good for a hobby project or a small project, but this technique has limitations. And again, it's costly because I fetched all 25 data, but my user was only limited interested in really knowing the recipe for Caesar salad. Everything after Caesar salad was a waste of data that I got from server. So I got more data from server, which was expensive for me to serve as a application builder, and it was useless to users. So it served no purpose to anybody. And that's why modern applications modern applications offer server-side uh, server-side uh, and I'll save this somewhere. So let me copy this. Modern applications offer server-side pagination. And what do I mean by that? So but this is the same component I just V2, so you guys have to both the versions. Previously, we were calling our API, and this was gets entire data. Instead, now I'm passing to my server what page currently user is on and how many items per page user wants to see. So in that case, now let's look at what happens. Did I change my? Yes, I did. Let me reload my application. So while it loads, I'm telling my server, so this is my React application, and this is my server. I'm telling it, please give me 5 items at a time. So give me items, and server gives back in cluster of 5 only at a time. This way, I'm not sending the entire data back to the user, and instead, I am sending the only chunk of data from server. So now if you look at our API request and the preview of it, all I got was as a data, just 5 items and other metadata, like what is the first item, what is the last item, how many total items I have. Because I do not have entire items array on my UI now, I need to know how many pages are there. So this metadata helps us do the same calculations that we did previously like this on the UI without actually needing to do them. So we don't have any more calculations. And if you look at the code side by side, let me see if I can. Okay. If you look at this code, our recipe list, we had this extra variables to do all the calculations manually because we were handling everything on the server side. Instead, now we have total pages a state variable, current pages state variable, and recipes. We are getting, besides current page, we are getting entire detail from the server in the chunk of 5 items. So next time when I click on the next button, I'm going to make another call of API. Previously, we just had one API call to our server. Now every time I'm hitting next, I'm creating a call to server, and it is giving me items and list of items and what page I am on. So next page is page 3. And similarly, if I do this, I get the third page items. So now I'm, instead of dumping everything in the UI at a time like this, I'm getting 5 at a time from server. This is much more efficient from the user perspective, that if user was only interested in one page worth of data, they will not be needing to, their browser will not have entire set of data. As well as it's cost effective for me as well as application builder and application server as a Wikipedia, not to send everything back to UI if it's not needed. So this is client-side pagination and server-side pagination. So quick recap, right? What we learned today, routing between pages. So if I click on fish and shrimp, I get the page of details with fish and shrimp, and I go to a new page called recipe and 11, and I can go back to my previous page and I'm on my recipe list page. And also, when you're working large, second topic we covered is when you're work on the large set of data, you don't want to show the entire data on the UI at the same time. And you want to chunk them in some meaningful numbers, let's say 5 items at a time, and show them in UI. You can do that either on the UI side where you get entire data dumped to the UI or your React application at the same time, and then break it out in the React, like we did in our initial component of recipe list, or you can fetch 5 items at a time, like we did in our second version of recipe list component. So that's about the topics we have to cover today.